I'll start getting moving in just a bit. I'll let people keep coming in. I see we're about 13 now, 14, 15. Any questions before I start getting us settled and moving?
Hey, Chuck, I have a question about, are we allowed to ask questions about the homework assignment since you're gonna go through the whole thing?
I mean, if it's something relatively quick, I'm gonna run through the entire thing. If you got just like one quick one, sure.
Yeah, so for the last set of questions about data frames, I am getting the same class type between the two ways of, I guess, like looking at the class within the data frame and then by itself as a vector. So I'm not seeing what's unusual. If I did it wrong or if that's...
Yeah. Let's think it's class of each column in data. If I want to see anything unusual about that character, get help on data frames. Data frame. I could do to modify this behavior. So what class is it coming in as?
Both are coming in as character.
As character. Okay. So, you know what this is? This is actually our 4.0 behavior I didn't update the homework for. It just occurs to me. I didn't change that. Before our 4.0, it would have come in not as character, but as factor. And I forgot to update the homework for that. So that's a note for that. It's one of those R 4.0 things I missed. So good find. Yeah, no, it should come in as a factor back in the day. Now it loads in what you'd expect. So that one is kind of dumb and I'll have to send, well, it's too late now to send out a clarification. I guess I'll send out a clarification. Let me set myself a reminder here to do that so that people know. Come on. Okay. Yeah, okay. I'll send that one out after lab. Okay, anything else?
So would the answer for that just be that before it would result in a factor variable and now it doesn't?
Yeah, exactly. If you already had our experience, you'd be like, oh, it's interesting. It no longer generates a factor, but for any normal human being, they wouldn't be expecting that behavior in the first place. So it would just work. Yeah. Okay, well, we're at about 3:33, so I'm gonna go ahead and get started here. So I'm just gonna kind of do the entire process of this thing. To start it off with, I would download this R Markdown template off the website. So I'm just going to go ahead and say, save this link as, I'm going to chuck it here in my ignore directory in here, crack it open in RStudio, and you should be confronted with a template like this. I assume most people have actually already worked through it partially, so you've seen this already. I'm going to swap this to my name here, put 10/26/2020 up there, and get moving. So if you haven't looked at this too much, you basically ignore this entire big chunk at the top. What this code is well, one, it's something that'll look a little bit more sensical if you make it through lectures 6 and 7 in this class, which are going to talk about writing functions and doing if and else type statements. This is basically a big ugly function that checks all the answers in the homework when it runs later. So this is how I'm checking the answers later. Okay, so I'm gonna kind of just go through these sort of one at a time, mostly soliciting answers out of y'all. If you get stuck on anything, I'll fill in. So we'll begin here with coding with atomic vectors. So I usually just say vector, and most people say vector when they're talking about things in R, but the technical term for these sort of simple vectors where each element has to be the same data type, you often see them called an atomic vector. So if you see an error message pop up in R and it says something about like can't subset an atomic vector, that just means you've got like a standard vector you're trying to do something to. Atomic vector just means a plain old vector. They're specific about that because lists are also in R technically a type of vector, which is confusing. Okay, so the first question, and I realized from sort of questions I get in chat and questions over email, this first one is a moderately tricky first one to start you out with. So what this one asks for here is use the sequence function, seq parentheses, to create a vector of 10 numbers evenly spaced from 0 to 15. So how do I go about doing this? Well, first, what's the function?
Sequence.
Yeah. So I've got seq here. Now, this first one suggested in chat is mostly there. I can say sequence 0 to start at 0, 15 to end at 15. But if I say by equals 1.5 and run that, it's going to take a second to run the stuff above it, and I check my answer, it's going to say here, check my code for vecnum. It has the wrong length or dimensions, and I seem to have an incorrect or misplaced value somewhere. So if I go up here and look at it, the issue with this, it goes from 0 to 15, but it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers rather than 10. Because if I start at 0 to 15, by 1.5, I get 11. So the solution to this is what the other people are sort of pointing out in chat, is there's another way to specify sequences using sequence. Instead of saying by a specific gap between these numbers, I can instead say, you figure out how wide of an interval to use. What I care about is that the resulting vector is length 10. So length.out equals 10. If I run that, vecnum, now it's figured out how to space them out properly. You'll see it's actually got these like 3.33333 repeating numbers. So there's really no by equals you could have manually specified unless you were very clever and you used a fraction to do that. If I rerun my checking down here, it's going to say, oh, good job on vecnum. This error down here is because I haven't filled in the next answer, but good job on vecnum. This is what it was looking for. It was looking for a length 10 vector that starts at 0 and ends at 15, which should give numbers that look like this. Yeah, you could, for instance, do what Santino is showing in here, which is you could use some sort of a fractional one and you'll get the exact same answer, but it's a little bit more clever than necessary for the problem. Though people who did that, if it works, it works. Okay, any questions about that before I move on?
Yeah, one silly R question is, when I run this, I'm not seeing the output at the bottom like you are, which makes me think I'm not running something properly.
So if you put your cursor, your caret right here on this line and hit Control Enter, what do you see? Nothing, right?
Control Enter.
Well,
Yeah.
the answer is you're not going to see anything. What I'm actually doing is I'm highlighting vecnum here, and I'm hitting Control Enter while it's highlighted.
Oh, gotcha. That makes sense. Thank you. You can also put the parentheses around the whole thing. Is that how it goes, right? Like, remember that? Okay.
You could do this if you wanted to also print out in your homework, and so that will do it.
Okay. Thank you. Appreciate it.
Okay. Anything other ones before I move on? Okay. I'll jump to the next one. So the next one is actually a little bit simpler. The next one is use colon to create an integer vector of the numbers 11 through 20. What does that look like? One of those not a trick question ones. Yeah. So we're basically saying I want to create an integer vector that starts at 11, goes to 20. So you can think of the colon as being sort of a go-to. It's a shortcut for the sequence function, but it will generate integers. If I go look at vecint, it's all the integers 11 to 20. If I run my error checking code, it's going to say, good job on vecnum, and then tell me that I need to put in an answer over here at vecCharacter. Okay. So could you use C 11 to 22? What's the difference? The answer is there's actually no difference at all. It's just the C is unnecessary. So what C says is combine something into a vector. The thing is 11 through 20 with the colon operator already generates a vector. If I put C around it like this, highlight it, it's exactly the same thing. The only reason you might want to put a C or a C function around it would be if you wanted to add something else to it. Like I could say 11 to 20, 21 to 30, and what the C would do is combine this vector with this vector, and that would work like that. So C is for combining things, but this 11 through 20 is already a vector, so I don't have to do anything fancy with C. So it doesn't hurt, just don't need it. Okay. So the next one.
Sorry, I found the code and I get the none.
You get what now?
Yeah, the result of the code is none.
Result of the code is, the result of this should be like vecint like this. If it's still null, you probably haven't run this line yet.
Okay.
Because it will be null to begin with because of this. This line here generates it initially as a null, but I override it. So if you override it with 1120 and run it, you should be good.
Okay, I will try again. Thank you.
Okay, the next one. Use letters in all caps and brackets to create a vector of the last 10 capital letters. So if we remember from lecture, I can show it in console here. Letters is just all the capital letters of the alphabet. So how can I pull out, using the square brackets, the last 10 capital letters? Yeah, there's a million of these that are good. Okay, the most straightforward way, as shown in chat there, is 17 to colon 26. What this says is give me the letters vector subsetted down to the 17th through 26th element, which is the last 10 elements. If I run this, it's QRSTUV, WX, Y, and Z, right? If I did instead sequence 17 to 26, I would get the exact same result. So if I write instead, as was done in chat, sequence 17, 26, this will give me exactly the same thing, 17 to 26. This is because the colon operator is a shortcut for that exact function. They do the same thing. A great question in chat, is there a way to do this with tail? Yeah, if I hadn't specifically said use the brackets, an equally good way, or even possibly a better way to do this, would be to say tail 10. The nice thing with tail 10 is we no longer have to figure out what is the 10th element from the end. Tail 10 just gives us the last 10 elements. This is the way that you might actually do it if you for sure wanted those last 10. I was saying use the square brackets. My homework doesn't care which one you use, but I was just suggesting square brackets to get used to doing them. But tail would be equally valid here. But it's all the same. And that will give us what we want. Questions on that? Sweet. Okay. So the next one, use letters, which is the lowercase version of this, and square brackets to create a factor variable using the first 10 lowercase letters. So there's two steps to this kind of. The first thing we want to get is the first 10 letters, but then we also want to make it a factor. What would this look like? Any part of this? Just getting the first 10 letters or also making it a factor at the same time. That's one way to do it if we wanted to pipe it, and that's the exact other way to do it if we want to do it as a nested statement. So I'll show you that both work. So I can straight copy this right out of chat. So this would be a way to do it with a pipe. This says, I'll first show you, get the first 10 letters, A through J, and this says take all those letters and then make them a factor. So if I run this, I'm going to get a factor. It's the same data, but now it looks like that factor way with levels and stuff. And this would give you the correct answer. The other way, and the way I sort of would expect it to be, most folks would probably think to do it, which is identical, would be to do it as it's done there by either Sean or Courtney in chat, which would be to say, take the as factor and put it here, and you're going to get exactly the same result. Because the pipe that, the first way I showed to do it from chat, is actually doing the exact same thing. So whichever way is more intuitive to you, they both work. And Sean's way of using sequence in chat there is exactly the same thing too. These are sort of 3 different ways to get the exact same answer. And you'll notice that she used factor there and others have used as dot factor. They actually do the exact same thing in this case. If you do as dot factor, it converts them to a factor. The factor function also converts things to a factor. Either one of them are valid. Yeah. So you could do it this way, or you could do it this way with just factor. You get the exact same results. We check it. Good job on vec factor. We're good. Make sense? Yeah. A little weird, but we're doing multiple things simultaneously. So the first thing it's going to do, it's going to take letters, then it's going to extract 10 letters from it, and then it's going to convert them to a factor. So it kind of works inside out. Okay, the next one. Use C to combine vec character and vec factor into vec let. I say do not convert it to a factor. If you just kind of let it do its thing, it won't make a factor. What would this look like? Not a trick question. Yeah. C, vec character, vec factor. I run this, I look at it, and we get QRSTUV, WX, Y, and Z, and then we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 instead of the letters. The reason for this is if you convert a factor to a character vector like this without using as dot character directly, it grabs the levels of the factor instead of their labels. Their labels are things like A, B, C, D, E, F, G, but their levels are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I take this and compare it to, so the first way that we just did it gives us that. If I manually convert it to character, it would give us back our letters. This is an oddity of R, where if you want to get the labels of your factor back, you need to specifically convert it first before combining it. If you want the actual underlying levels, you just do it without converting to character. This is a weird design decision, and it's something you'll probably rarely encounter or have to mess with, but just know that it'll happen if you're combining a character vector and a factor vector. You probably want to convert it to using as dot character first. So that's just a heads up. Okay. Some people actually did that because they probably have some prior R experience and were like, why isn't this working? It's like, well, I'm kind of expecting you to not know how to do that yet. Okay. So the next one, use combine and square brackets to combine the first 4 elements of vec num with the last 4 elements of vec int to make vec ni. So what's this going to look like? There's a couple different parts to this. You can give me part of it, or you can give me all. Okay, I'm going to grab that straight from chat. See what that looks like. So this one says here, I'm going to combine. What am I going to combine? Vec num elements 1 through 4. That's the first 4 elements of vec num. And then combine that with vec int 7 through 10. It's a length 10 vector. So 7 through 10 positions should give me the last 4 for a vector that looks something like that. See if that's right. Make sure I run that one, that one. Looks good to me. Another option here would be, and this one should work from the look of it. This is a slightly more complex, but also more flexible one here. This looks like a lot of code, but it's actually fairly straightforward. So I'll run this and show you. So what this is saying is still combine the first 4 elements of vec_num. But the clever thing here is saying, take vec_int and give me the third, or rather this is the taking the length of vec_int, which is 10, subtracting 3 from it. That's the 7th element of vec_10, so 4 from the end basically, and go to 10. So this is actually the number 7. This is the number 10. The whole thing is the same last 4. The neat thing about doing it this way is if you do it this way, if vec_int actually had length 20, this would work exactly the same way, grabbing the last 4 elements of vec_int, no matter how long it is. This is a more flexible kind of programmatic way of doing it. So this is a nice way to do it. So here's one I missed here. I must be confused about something. Vec character as character vec fact isn't working for me. That's correct. That will not work. So this here is what I'm expecting to see. If you do as.character vec factor here, you get a different result. You get the A, B, C, D, E, F, G, H, I, J. But if you don't convert it to character first, you get numbers over here. So my expectation here is this rather than converting it to character. The reason for that character conversion is as.character specifically replaces the values of a factor with their levels before, or that's what as.character rather does on a factor. It's a weird thing, but maybe you'll want to do it sometime. I'm not expecting you to do it here though. Okay. So this is straightforward for this. This is a more general solution for an arbitrary length one. Either one works. And then lastly, use REV to reverse the order of vec factor and assign it to fact vector. What does that look like? Once again, it's not a trick question. If you didn't know how it worked, you could do $REV, or you could just try it without looking and see what it does. What's that look like? Yeah, there we go. We're going to say reverse vec factor. What does this do? This is the reversed factor. This is the original one. You'll see that the levels stay the same, but the values here are being flipped. So what reverse does is it actually just takes that vector, basically, if you imagine it as a column in a data frame, and it puts it upside down. It just flips the order. Okay. Here's a question. I got this error when running a test. What does this mean? Error in test, blah, blah, blah. Ignore all that. The important part is object vec character not found. This means that you did not run this line up here on 135. It's saying vec character doesn't exist, so it can't find it. Make sure you've run all the stuff in this chunk, and then run the tests, and you should be good. I am going to send out the video of this lab. Yeah, I won't send out the sheet itself, like the final one, because it's literally an answer key. But I figure anyone who's willing to sit through and watch the entire lab, you know, they're working through it and doing stuff on their own. Okay, yeah, if you want to work through them on your own, I highly encourage that. So, yep, let's kind of give people different options for the pace. Okay, so any questions on the vectors? Any other problems? Okay. How about this one? Missing value or true false needed. So that depends on the line where that error is popping up. So that's indicating you've got a missing value somewhere. Does it say what line that error is on? Vec NI. So That's saying here that you have some sort of issue. Most likely you have missing values somewhere. Do you have vec int 7:10 here? Is that what your code looks like?
Oh, oh yeah, I see. I have 17. Oh.
Yep, 17:20. Yeah, so the thing is there, if we put 17:20, this does a weird thing. The code will run, which is funny because you'll notice vecint only has 10 elements. Why does it let me subset to its 17th through 20th element? It's dumb. The idea is that it's looking in the 17th through 20th position, but it doesn't find anything. So it says the 17th through 20th elements are missing. So it returns NAs. So what was happening in your example is you were getting 4 NAs over here, and it was kicking an error my homework wasn't looking for. Okay. Run that, make sure this is good, and then good. Okay. So I'm going to skip over the sort of little short questions here, which are sort of thought questions, and go straight to the code. So the next thing will be coding with matrices. Okay. So the first one here is use matrix to create a matrix with 10 rows and 4 columns filled with NAs. How do we do that? And if we didn't remember from lecture or anything, remember, you can do like $matrix, and it will bring up a help file. The help files aren't always the most useful, but they're a good place to start if you're not sure how to do something. In this case, you'd look at matrix over here and see the matrix function, and then see it takes like data equals, by default, NA, a number of rows, a number of columns, a by row, dim names, which would suggest the kind of things we might want to fill in for this. Anyone have an idea how I can make a 10-row, 4-column? Ah, here we go. So I'll take this first one. It's the same as the second one. So what this says here is I'd like to make a matrix. The data that are going to fill this matrix are NA. Fill it with nothing but missing values. Give me 10 rows. Give me 4 columns. If I run that, what we're going to get is a matrix of 4 columns, 10 rows. If I run my little check here, it's going to say good job on mat empty because it sees a 10-row, 4-column matrix where every element is an NA and the whole thing is a matrix. Okay. Yeah, you could also, this is a good point, because the first argument is data, the second argument of the function is the number of rows, and the third is the number of columns, you could shorthand this and just say matrix 10-4, and you'll get the exact same answer. In R, you don't actually have to name your arguments by saying like nrow equals and ncol equals, as long as you provide them in the order that the function documentation specifies them. So Courtney's answer there is exactly right. It's a way to give a shorthand, and then we do it all the time without thinking about it. When I do things like, specify something like right filter and then just specify some variable in gapminder like country equals that, we're actually giving an argument to this function. We're not naming what that argument is, but you can directly and manually name them if you want like this, and it's a good way to make sure you're putting the right stuff in. Because if you do it this way, you don't have to put them in order anymore. Like this will work without changing it to being a different matrix. Just a thing to know. Okay, so we've got our empty matrix. Next one. Assign vec_num to the first column of mat1 below. So if I want to take mat1 here and assign vec_num to its first column, how do I go about doing that? And note for these ones, you're going to have to modify stuff not just on the right side of the assignment operator, but also stuff on the left side of the assignment operator. Yeah, there we go in chat. I like the look of that. So what she says here is we're going to say mat1, subset it to mat1's first column, and then we're going to assign to that vec_num. If I look at mat1 now, mat1 has in its first column the vec_num we created with sequence earlier. Okay, so the idea of what's going on here is something that's interesting. There's a symmetry to subsetting in R. So you think of subsetting as like giving R an address If you just give it an address, it basically takes you to that place. So if I say, let me look at mat1, it returns the contents of mat1. But if I give it an address and send something there with assignment, it overwrites whatever is there. So assignment operators are sort of something symmetrical. They can either, not assignment operators, but subsetting operators. You can either use them to pull something out or to put something in if you use an assignment on it. Does that make sense? Okay, let's go to the next one. And also, I guess I'll run this and make sure it says that I did it right. Yep. Okay. So the next one, assign vec int to the second column of mat2. What does that look like? It's the same basic operation. Vec int, and where is it going? Yeah. It's just repeating the same one. This will send it over. If I look at mat2, mat2 now has our integer vector in the second column and our numeric vector in one. Okay, now shake it up a little bit. The next one is assign vec character and vec factor to the third and fourth columns of mat3 using a single assignment operator. Okay, how would I be able to assign these simultaneously to these two columns? A couple ways to do this, but one very much more straightforward way. You can give me parts of this. Oh, give me the whole thing. That'll work. So, this is an interesting one. So, technically, both of these will probably work for weird ways. I'll look at the first one. So, this is an interesting approach. So, this is interesting and might work. It does. This is great. This is an example of R being a little weird. So what is this thing over here on the right? This thing on the right doesn't have two columns. This thing is just a single length 20 vector. The idea here is if we say mat3 is third and fourth columns, what it's going to do is it's going to fill the third and the fourth columns element by taking values from this length 20 vector we've made over here. What it's going to mean is the first 10 values, which are vec character, are going to fill up the first column. The second 10 are going to fill up the second column we've selected. This is going to result in us filling this basically with vec character here and vec factor over here. This is still a little bit odd, though, because we've essentially filled something rectangular with something one-dimensional. It's a little weird, but it will work perfectly because of the way R writes things to matrices. The more conventional way that I normally think of would be to C-bind these things together. So if we say instead of combining, so note what combining does here, it gives a single vector. If we instead C-bind these things together, each one becomes a column in a matrix of its own. So cbind says take this and make it a column, and take this and make it a column, put them together into one matrix. Now, if I assign this to columns 3 and 4, we also get the exact same result, but it might be slightly more intuitive because it's already, this is two columns of a matrix going into something that's exactly the same shape, but either one will work just fine. So here's a question. Why doesn't mat3, 3, 4 work? Why doesn't it work? Appears to work for me. I can't see any reason why it shouldn't work. Work instead of mat3. So what is yours doing that is not working? Should work for both of these methods too. Those should both work. Incorrect number of subscripts on the matrix. Check and see what your mat3 object looks like. Is it a matrix? It is. That's curious. Incorrect number of subscripts. Mat3, 4. Yeah, I literally copied the exact code. And it seems to work for me. Let me double check that. Yeah, your literal code copied in there works perfectly for me. So I'm not entirely sure what would generate that error. Incorrect number of subscripts on matrix. Fact. Correct number of subscripts in here would normally mean that getting the same error, it looks exactly like this. And your mat3 looks like, so at that point, your mat3 should look like that. And your mat3 looks exactly like that, but that code is giving you an error like this. Does this look like that? Like, oh, this should be a length 20, or the C bind one should be 2 like this. And if you run exactly this line right here, ran it again from the top and it'll work. Yeah, I would suspect that will fix it if you run it all from the top. It's most likely actually due to the vec character or vec factor not being having been run earlier. Yeah. Okay. When in doubt, restart the whole thing. Basically, run everything from the start. It usually fixes problems. Make sure these are right so far. Okay. Okay. Next one. So what we want to do is select the 4th row from mat3 and assign it to the object row 4 as a vector. So how would I pull the 4th row out of mat3? Just want its 4th row, yank it out, and spit it out as a vector. I'll say now we don't have to do anything special to make it come out as a vector. Yep, that'll work. Mat3, we're saying I want row 4. I want every column. So if you do comma blank, comma nothing, it's going to give me every column. This will generate the 4th row. If I look at the matrix here, the 4th row is 5, 14, T, and 4. 5, 14, T, and 4. It will pop out by default as a vector. Don't have to do anything special to it. That just works. Okay. The next one. Assign the element in the 6th row and 2nd column of mat3 to val62. So it's just adding one more dimension of subsetting here. What does that look like? Aha. Excellent. So we start with val. This is the 6th row, the 2nd column. The thing is if I run this, you'll see it's in quotes down here. By default, it's not numeric. It's coming out of a character matrix. So we're going to add, as suggested in chat, as .numeric to it. That will convert that 16 to an actual numeric 16 and assign it there. So this is another one of those 2-stage ones. We do the subsetting first, then we convert it over, and we get val62, the number 16. Okay. The next one, use, why didn't we use as factor for this row 4 mat342? So row 4 mat34. So there's no reason to. So mat34t here pops out as this nice character vector. We don't have any reason we want to turn it into a factor. I usually would recommend only making things into a factor if you've got a good reason to make it into a factor. You usually, if you don't know whether something should be a factor or not, it probably shouldn't be a factor. We'll specifically work with factors a little bit this week. I think this is week 5. Time flies this term. Been super sick for like the last 2 weeks too, so time is really just flying by. Yeah, we're going to spend, I think, a little bit of time with factors on Wednesday, and you'll get to see probably a better idea of when to use them. Plotting is a common time to use them. Okay, the next one. And never apologize for questions. These are always good questions. I like it, and that's the backbone of this class is people asking good questions. Because I could just brush over all the stuff and you'd miss all the important stuff. Okay, so next one. Use cbind to combine vecnum, vecint, vecCharacter, and vecFactor into mat4. So how do we do that? It's not a trick question, but it's something we haven't done much of. Do what it says on the tin. I like it. Exactly. We'll say, we'll cbind vecnum, vecint, vecCharacter, and vecFactor. Okay? This is something that's kind of neat. So cbind, much like the standard combine command, can take an arbitrary number of objects. Okay? I can put as many columns as I want in here, and it's just going to make them columns in a new matrix in order. If I cbind these, I'm going to end up with a matrix that looks like this, which should look familiar. This is exactly what our existing matrix mat3 looks like. Basically, we produce the exact same matrix. The only difference is, notice, when we put them together manually, the columns just have column positions. But if we use cbind to put them all together, they keep the names of the objects used in the cbind command. So this is a little nice thing cbind does, is it tells us kind of where they originally came from. We cbind them together, it makes them the names for the columns. Okay, little thing. But cbind just turns vecnum into the first column, vecint into the second, and so on and so forth. Okay, you can create data frames the same way. So if you use data.frame instead, it makes a data frame out of these. Okay, the next one. So this is a mildly complicated one. It says, first transpose mat4, then select only the first 4 columns and assign them to mat_t. So she's quick on the draw here. Got one in chat suggesting this. The additional parentheses on the outside will make it display also in the console when run. But what this says here is, well, we first want to transpose mat4. So she's done transpose mat4. So what does that do really quickly? This is, oh, I have to run this. This is mat4, right? Like this. What transposing mat4 does is it rotates it down. So the things that were originally column names are now the row names. And this has gone from being a 4-column, 10-row matrix to being a 10-column, 4-row matrix. It's flipped the columns and the rows. Okay? And then from this transposed matrix, we're going to grab its first 4 columns. So if we do that, we see its first 4 columns. So it's now a 4x4 matrix. Run that. Got it like that. Let's see if this if it likes it so far. Yep. Okay. So that's a mildly complicated operation because we're doing 2 things. This is an important thing to realize about R. In general, R does the thing on the left side before the thing on the right side. So in this case, it's saying I'm going to run this function transpose mat4, and after it's done transposing it, the subsetting operator takes place on the result of that thing. Okay. Lastly, let's use rbind to add the rows from mat3 to this. That is mat_t first, mat3 second, and assign it to matbig. How do we do that? So rbind's kind of like cbind. Rbind takes vectors and makes it so each vector you put in becomes a different row in a resulting matrix. That's the answer there. Rbind mat_t first, and then we're going to rbind mat3 to it. What does this do? Results in one big hideous matrix. Mat_t is the 4x4 matrix that was right here. Mat3 is all the values that got bound below it as additional rows. So it took the first matrix, mat_t's rows, and stacked them on top of mat_3's rows. So you can imagine cbind takes vectors and squishes them together. rbind squishes them the other direction. Okay, rbind squishes things vertically, cbind horizontally. Okay, run that. Check my values. They look like they're good. Do we have any questions on that before we move on to data frames?
There's lists first, right?
Oh, lists, yes, not data frames. Yeah, lists. I was thinking my mind is lists as being more complex than data frames, so I would expect data frames next, but it's good to do lists first. Because in reality, data frames are oddly more complicated than lists. They just don't look like it. Okay, so let's jump over here to lists. Okay, so first one we want to do is use list to create a list that contains vecnum and row 4 and assign the names vecnum and row 4 to these two elements of list 1. So we want two named elements. They're named after what they are. How do we do that? So we're using list, the function. It says it in the question. But what am I going to do inside of that? Okay, I like the look of that one. Copy and paste that. So this says here, I'm going to make a list. I'm going to name vecnum here is going to be equal to the vecnum vector. Row 4 is going to be equal to row 4. If I run this in my console, we'll see we get a list where the resulting list's first element is vecnum, contains all of vecnum. Its second element is row 4, and it contains all of these. I assign that to there. I'm going to run my check. Looks pretty good to me. So the way this works in list is you can provide a name for something first and say the contents of that thing, that element, are equal to whatever is on the right. This is actually something you can do when you generate data frames, and you can actually do this when making vectors too, but I haven't shown examples of it too much in this class. Name goes first, object that goes there on the right. Second. Okay. Next. Using the $, extract row 4 from list 1 and assign it to the object row 4(2). So here we go. Is there a way to do that automatically since the input variables are also the names? Well, let's see what happens if we take that. Okay, it doesn't automatically do it with list. I feel like there is a way to automatically do it. Will that do it? Nope. Okay. Yeah, I don't think there is a way with the base list function to automatically give the names. There would be a roundabout stupid way. The stupid way would probably be to go as.list data frame vecnum row 4. But that's going to give me an error because they're different lengths. It would work for anything equally length, but it's a stupid hack. Yeah. I don't know of any way to make list grab the original object name. Yeah. Kind of weird. Yeah. Yeah. Strange. Yeah, nope. Doesn't do it. Okay. So the next one here. Use the $sign to extract that. So how do we go about doing that? I want to pull row 4 out of list 1 using a $sign. How do I do that? Yeah, that'll do the job. List 1, $, row 4. Okay. This will extract back out the row 4. So this is like subsetting a column out of a data frame using that $sign operator we showed before. This says, look in list 1, extract from it row 4. Okay, so that'll work. Next one, create another list that contains val62 and mat big. We don't have to name it anything. You can if you want, but we don't. So how I'm just make another list containing those things? I'll take it. List val62 mat. Oh, no. Autocomplete killing me. Mat big. Okay. Should be something that looks like this. Val62 is the number 16. Mat big is this big, ugly, big matrix. See if this looks like what I want it to. Good job on list 2. Okay, so that did it. Just jamming two things together. Now, combine list 1 and list 2 together using C and assign them to list 3. This is another example of sort of do literally exactly what the text says, and you will get the answer. Try not to brutalize people with list stuff, because lists can be a little bit mind-bending. So this is literally just saying use C to combine these. So combine list 1, list 2, and that'll do it. So notice the interesting thing about this. We've used the C combine function to combine vectors together, but we can combine entire lists together with it also. So combine works equally well on simple vectors as it does on entire lists. So this right here is list 1, which contains vecnum and row 4, and this is list 2, which contains val62, but we didn't name it, and mat big, which we also didn't name. So by combining them together, it just sticks them together end to end by their like elements of the list. This is element 1 and 2 of the first list, element 1 and 2 of the second list, which becomes 3 and 4 in the new resultant list. So combining things with C when they're lists can be confusing and weird, but it works exactly the same way as combining things with standard vectors. You just have to remember with a list, this vector, for instance, is one element from the list, even though it has itself many elements. Okay, lists are weird, right? Okay, now we're going to do something weird. This says use unlist to turn list 3 into a vector and assign it to vector 3. I'm not soliciting an answer for these because this is literally follow the instructions and more like see what happens. I'm going to say unlist here, list 3. Okay, let's look at the result of this. If I say unlist 3, we get a really weird thing out, okay? So if we unlist a list, what it does, unlist takes a list and converts it into a standard vector. But the way it does it is a little odd. It just strings all of the sub-elements of these lists together in order. So if you look at the original list, it's vecnum 0 through 15. If we look at this new list, it goes vecnum 1 is 0, vecnum 2 is this, blah, blah, all the way to 15. So this right here is the first element of the old list. This is the second element of the old list. This is its third element. And this thing was the fourth element of the original list. It's just taken these things and made a vector so that you have this vector, and then stick this one right onto the end of it, this one right onto the end of that, and then this gets turned from a matrix into a vector and stuck right on the end of it. Unlisting is an operation one does not use very often because it deletes all of this useful structure of the list, but you might do it in certain cases. Let's say you're doing something like working with Twitter data you've pulled down or something, which might come out in an interesting list. You may actually want to just concatenate all that data into one big vector for something like a natural language processing or something. This is a more advanced thing, but every once in a while you just want to take something like this and digest it into one big vector. Okay, so the thing about that is, logically speaking, if using unlist turns this nice structured list into one big vector, what do you think will happen when I take this sort of unlisted list and I turn it back into a list using as.list? What's it going to look like? Is it going to reverse the operation I just did? Yeah, I see people on here nodding no. This is a thing about R. If you destroy something beautiful in R, it is probably forever broken. It does not get structure back when you try and add it on. If I take a nicely structured list like this and unlist it, if I make it back into a list using as.list, it's just going to make every single element of that vector an element of a new list. Okay, this is an important kind of simple thing to R. R does not preserve structure if you remove it most of the time. If you want something to be a list and you want to keep this list structure, don't make it a vector. Similarly, if you want something to be a data frame, don't make it a matrix because you're going to lose all the things that make it a data frame. Okay, so you can unlist something, but you can't relist it. You can't relist it back into its original shape. There's no way to recover that. Okay. Would you give a practical example of lists? When do you use these? So lists are for people who, as soon as you move out of working with kind of flat files of data and conventional, kind of, once you're not working with spreadsheets, if you're not doing basic data analysis, you're going to probably end up working a lot with lists. So lists are, for instance, all statistical models you run in R are generating lists. If you need to extract anything directly from them, you need to know how to work with lists. If you want to write your own statistical routines, you're going to need to work with lists. But by and large, the tools that I teach in this class and the more advanced tools in the Tidyverse are about making it so you don't have to use lists because they are hard to work with. But if you're pretty advanced in R, you work with lists a lot sometimes, but I usually use them to do nuts and bolts kind of stuff. Mostly I'll do things like if I'm writing my own statistical routines and stuff, I'll use lists to do it. But most of the time, you're not going to have to do it yourself. Though you will see a good applied example. I won't say a good applied example. You'll see an applied example in week 6 when we use lists to run a whole bunch of regression models and plot results from all of them at the same time. When you do something like that, each regression model result will be an element of a list, and then you'll iterate across all the elements of the list to do plots, and cross-validation is actually the example I'll do in week 6. Could be common, but you could also escape almost ever working with lists in your R career if you really wanted to. Yeah. Okay. So that's 5 and 6. Now we're going to get back into ones that are like, how do we do this? So you'll notice that this is an unusually long question in this one. This is because the thing that I want is not super complicated, but it was really hard to write in words. And this is iteration like 10 of the instructions for question 7. So this is my most recent best effort at communicating the thing that I want. This says, now copy list 3 as list 4 and use double brackets to assign list 3 as the last, that is 5th element of list 4. That is, you should have a list object with 5 elements named list 4 that contains the same 4 elements as list 3 plus a 5th element that is all 4 elements of list 3 as a single object. This is actually a very simple thing, which is hard to write in words because it's a dumb thing. I did this in 2 lines with 2 operators. Yes, that is exactly what my intention is. So the very first thing, right, is we want to copy list 3 as list 4, right? Well, the first line then, let's copy list 3 as list 4. So what's the next step of this? So once we've copied this, we need to assign list 3 as the 5th element of list 4, so that list 4 is all of list 4, yet also manages to contain itself as its 5th element. Or is this still just a confusing question? Oh, that looks exactly right to me. You always know you're on the right track too. If multiple people in the chat say at the same time, that means you're probably right. Okay, so the idea here is we copy list 3 over to list 4. What does list 4 look like? It's this big ugly list. Okay, but now what I'm going to do is say, let's assign list 3, which is this whole thing, to the 5th element of list 4. And what do we get? We managed to get something even uglier. So this is the original list 3. And now we've added as a 5th element the entire list nested again inside of here. Lists are weird, okay? So the thing with lists is they can have an arbitrary number of things in them, arbitrary types of things, and they can be nested super deep. If I run now, structure list 4, this is the structure of list 4. It has these elements, vecnum, row 4, this unnamed number, and this one. And then it has another element, which is unnamed, the 5th element here. Within that, it has its own additional elements here, which are vecnum, row 4, and this. So structure is a nice command because it allows us to visualize the hierarchical structure of a list. If I wanted to do something, I think the next example is grabbing something out of it, so I won't say it. But this lets you show how you might subset something out. Like if we wanted exactly this row 4 here, we would have to subset down to this element and then this element within that one and pull it out, which I think is basically what we're going to do in a second. Lists are unpleasant, but I showed them to you because sometimes you're going to have to work with them, maybe. So here's a question. Would this give the same result? List 4 with list 3, 1, list 3, 2, 3, 4, and list 3. Yes, actually, that would give you the same result. Though I think the names would come out differently, would be the only result. I think that would generate... Yeah, the only difference there is you would lose the names on the first 2 elements. Otherwise, it's exactly the same result. Okay, so the next one. Next one, select the 3rd element that is the sub-element of the 5th element of list 4 and assign it to element 5.3 using double brackets. So there's 2 subsetting operations going on here. Select the 3rd element of the 5th element of list 4. So what we want first is the 5th element of list 4 and then the 3rd element of that. How do we do that? I like it. Yeah, like pulling a chunk of beef out of a stew. Okay. So this one says here, go into list 4, go to the 5th element of list 4, and then go to the 3rd element of that 5th element of list 4. Now here I actually want us to be using double brackets, but I'll show the result of this. So this is an interesting thing. When I use the single brackets over here on 3, look at the result. I get the number 16, but you see how I have this double bracket 1 above it? This is actually saying that the output of this, and I can show you here, the output of this is a list. If I want the actual element itself, I need to use double brackets. If I instead go double bracket here, you'll notice I just get the number 16 out. I don't get this additional subsetting thing appearing. And if I run class on this, ooh, it's a numeric vector. So the double brackets are important. Single brackets pop out a list. Double brackets pop out the actual element. So the next one down here is saying, repeat the previous thing, getting the 3rd element of the 5th element, but extract it as a list instead of a scalar. So to do that, we do it with the single brackets. So the difference again, this is a single length 1 vector, the number 16. This is a list containing a length 1 vector with the number 16. Single and double brackets are a weird thing. R is a strange language. You get intuitively used to it. Okay, questions about lists before we move on to our old friends, the data frame. Nothing? Okay, I'm going to run all this. Good job on all those. Actually, hang on. Working okay? Good to move on? Or still saying it's the wrong object class. So, oh, so your check is saying the wrong object class? Ah, for element 5.3. Okay, so most likely what that is let's see, element 5.3 is number 16, which is coming from val 6.2. Is your val 6.2 from the vectors or from the matrix? I remember this is from the matrix one. Is this a numeric? So that's coming out numeric and looks fine. But this is coming out and saying element 5.3 is not numeric. You might look, so element 5.3, oh, check element 5.3 and your console returns 16. Ah, okay. Rerun this chunk and then rerun the check. And is it still saying that? Making sure that you've got the double brackets here. And it's still doing it. Mysterious. Hard to know. Something funny somewhere. So if list 5.3 is element 5.3 is returning that, looks like a 16 and is saying not numeric. It is a mystery where that'd be coming from. I'd have to, okay. So let's see what would cause that. So list 3, list 3, list 3 is list 2, val 2 going to that. So when you look at list 4, the whole object does element 5.3, 16, look at that. It's actually coming back as a list. So here on 275, you're subsetting with double brackets here on both sides. Because it shouldn't be able to come back as a list if it's double brackets on both sides. And that's coming out with a list. So if you copy that exact code in there, you get like this. It comes back not as numeric, but as list. It's boggling. Because that shouldn't actually be capable of producing a list as an output unless there's yet another, only after running the chunk. Ah, so check and make sure that this is element 5.3, there's double brackets here, and that this is list 5.3 here and single brackets here. There aren't the same names, like it's being overridden or anything. Weird. Could just send me the RMD and I'll take a glance at it. And it's fast enough that if you send it to me and I open it up really quickly, I can look at it without really interrupting this. Okay, can I explain 7 again? Okay, so what does the double bracket do? I'm still a little bit confused to what question is asking. Okay, so this is saying that what I want you to do is to take list 3, make a copy of it, and then I want you to add on to that list the entire list itself as another element. So essentially what I'm saying is that this list has, by default, it's got it's kind of a mess here, right here. There we go. It has 4 elements. So list 3 here has 4 elements. Element 1, element 2, element 3, and element 4. What I want is to add a 5th element that is all 4 of these elements stuck into one slot in the list, basically, just to show you that lists can do weird things that you nest. So what I'm saying is we're going to add a 5th element to this list, which is this entire list. If I do that, we get this big, ugly list that is the first 4 elements, and then all 4 of these elements stuck into one 5th element down here. The structure is easier to see using the structure command, which shows that there's 5 elements here. This last element itself is a list containing 4 elements, which are the same as these 4 elements up here. It's a weird thing that is kind of purposely confusing. Don't expect extra meaning out of it. It's just to show you can stick a list inside of itself or inside of another list. You can do arbitrary things with them. The important thing is knowing about square brackets and subsetting. If you want to assign something to the 5th position, for instance, of a list, you want to use the square brackets here are saying, I want the actual contents of the 5th element of this list. If you use single brackets, it says, I want a list containing the 5th element of that list. It's a small nuanced difference. Single brackets return a sublist, that is a list containing the elements you're looking for. Double brackets return the actual object itself, not in a list. You kind of just subset the same thing with and without double brackets and see what happens. Okay, yeah, it's a little bit weird. Lists are weird. Showing up as correct, my brain just edited out the intermediate step because I didn't think I could have possibly had 2 in a line. Just moving. Yeah, there you go. Last line you had that. It was just overriding, yeah, the list. I figured it was something like that, that somehow element 5.3 was being overridden with the one list subsetted. Yeah, if someone else is still having that problem, look for that sort of thing. Hopefully it'll be it. Okay, moving on. Last section, data frames. Okay, so what we want to do here is use data frame to combine vecnum and vecint into df1. This is not a trick question. What does this look like? Anybody? Got to make people type something. Yeah, not a trick question. Data frame, vecnum, vecint. So if I look at df1 I just created, we're going to end up with a data frame with vecnum and vecint. So data frame works by default like cbind, kind of. If you give it 2 vectors, it binds them together as columns in a data frame, though, instead of in a matrix. Okay, looks pretty similar. Okay, the next one. Use $sign to extract vecnum from df1 and then reverse it with rev and assign it as the vector vecnum2. So there's 2 steps to this, which could all be done in kind of like one go. What do we want to do here? We extract vecnum and then we reverse it. That's one way to do it. So this is a way that literally shows the order that we want this done in. This one, it says, take data frame 1, extract vecnum, and then reverse it and assign the result of this entire thing to vecnum2. That's sort of a tidyverse sort of style piping operation. An equivalent way to do this would be to say, reverse it like that. These are completely equivalent. So do whatever makes sense to you. I tend to only pipe if I'm going to do multiple pipes, but they are exactly equivalent statements. This one says we're going to take data frame 1, extract vecnum, and then reverse it. It reads inside out, so it's less convenient than the one above it, but it's more conventional our syntax here, but they're completely equivalent. Either way, you're going to get vecnum looking like that. Okay, next one. Use $sign to add vecnum2 to df2 as a new column with the name number vector. So how do we add a new column using the extract operator to this? What's that going to look like? This is another thing about subsetting in R again. It's symmetrical. Any command you can use to pull something out of a data frame or a list or something can usually be used to add something to it. Got an idea here? I like it. Copy that straight from chat. So here, what we're going to do is we're going to say, we're going to take data frame 2, extraction operator number vector. The thing is this doesn't exist yet. If I use this operator with number vector, but assign something to it, it will add that column to the data frame. So right now, df2 looks like this, vecnum and vecint. If I add vecnum to it as number vector, it will add a new column to it, which is just this one reversed. Okay? So that's something nice to know about the extraction operator. It can be used to extract things, but it can also actually be used to add named columns to a data frame. This ends up being the new name. This is the contents, which gets added to it. Okay. Next one. Let's combine df2 with itself using rbind to create df3. So how would I rbind df2 to itself? Yeah, straightforward, right? Rbind df2 and then just do it again. And there's no clever way to say like 2 times df2 and do 2 of them. We just got to do them twice like that. We do this, we're going to end up with df2, which just has 20 rows. The first 10 are identical to the next 10. So if I click these buttons, it doesn't do anything because it's showing 10 rows at a time. Okay, so you can rbind data frames together like you can with matrices. It works. Okay, next one. Create a new data frame, df4, using data frame that contains the following named columns in order. So this is a bigger question. You need to make 3 different columns in this data frame. We want one that is the numbers, contains 20 numbers evenly spaced from 31 to 125. One that has 20 numbers between 0 and 10 generated using R uniform. And color, which is 20 values sampled, but you don't have to create it because I already made it here. So let's do it bit by bit. So we're going to use data frame. So if I want a Y that is 20 numbers evenly spaced from 31 to 125, what do I do? This goes back to our very first question in the assignment. Yeah, I like that. So the first one is going to be sequence of 31 to 125, dot out equals 20. And we're going to say that the Y variable in here is going to be that. If I run this as a data frame, we have a Y column that starts at 31, ends at 125 with 20 rows, because there are 20 elements to the thing we used to create the data frame. Next one. Okay, we want to create something, a column X, That's 20 numbers between 0 and 10 generated using R uniform. So this is an example again to demonstrate help. I haven't shown you how to use this function in lecture. This one would force you to look it up. So I say here, get help with $R uniform. Okay, so this says the uniform distribution. These are functions here that we can use to get information about uniform distributions. In this case, I say, what we want to use is R uniform. It takes arguments n, minimum, and maximum. N is the number of observations. Next one is minimum, maximum. So as suggested in chat, we can get this like so. This will say, I want to generate random numbers, 20 of them, that are at minimum 0, at maximum 10, and it's a uniform distribution. It'll look like something like that. Every time I run it, I'll get a different series of numbers because they're random. Okay. Next one, we want to make color equal to colvec, which is not a trick one, so I'm just going to do it. We're going to say color equals colvec, because I just created it here. And this will give us a, whoop. Oh, what am I doing here? 657. Which one is getting really big? Oh, duh. Colors 20 values sampled from colvec using sample. I got ahead of myself. Yes. So what we want to do is we want to use sample on it. So how does sample work? So I look over here at sample and it says sample takes X, size, replace equals false, probability equals null. Okay, well, what is this? Sample X. X is a vector or one or more elements from which to choose. Oh, well, it sounds like that's probably what I want to sample. Here, and then I want a positive number, the number of items to choose from. Okay, well, I want 20 items. This should sample my call vector and return to me 20 numbers. Okay, so now I have a data frame that contains a bunch of randomly sampled things. Okay, if I do a quick check over here with my data frames, it's probably going to say I have an incorrect value. The thing is this is checking for randomly generated numbers. Those randomly generated numbers will only be the same if I knit this document, but they won't be the same if I keep rerunning random stuff in my console. If I knit right now, it should say, come on. It should say, good job on data frame 4. The values are correct. Okay. Okay. So next, this is code you can ignore. This will just generate a plot that will show those values and colors. Next, use cbind to combine df4 and df2 into df5. Okay, what does that look like? These last two are not trick questions. So if I want to use cbind to combine two data frames, what do I got to do? Making people type. Nobody feels like typing. Yeah. So cbind, df4 and df2 together. And the thing is, if you cbind two data frames together, they don't turn into matrices. They don't turn into one big matrix. It keeps it as a data frame, but it still binds the columns together. So this tells us kind of something interesting about cbind. Cbind takes, if you give it data frames, it will produce a data frame. If you give it matrices, it will produce a matrix. So it works differently depending on what objects you give it. This is a universal thing in R because it's a type of object-oriented programming language. Commands like cbind do different things with different types of objects. Okay, so now we've got one big data frame, which is all of df4 and all of df2. Lastly, let's use data frame to do the same thing. Won't make you all type that. df6, I'm just going to say, let's use data frame, df4, df2. If I run this, what we're going to see is literally the exact same thing. So the idea here is that if you run cbind on two data frames and you run data frame on two data frames, they do the exact same thing. Taking a data frame of data frames treats each of these as sets of columns, which is what cbind does. So these are actually identical functions for the purpose of data frames. Okay. It's going to tell me I did it bad on df4, but if I knit it, it should say everything is just dandy. Good job on everything. Makes you feel good. Let me make sure the other ones look good. Good job, good job, good job. Ah, patting myself on the back. Okay. So that is what we have for the actual content. As far as these sort of answer ones, these are kind of like thought questions. Just kind of read them, look through them, give them an answer. I'm not going to walk through those ones, but I can answer them after the homework, you know, in class tomorrow, or not class, but Wednesday or something like that. But just kind of give them an eye, work on them yourself, and time to think about them. Otherwise, that's everything we got. Any questions on any of this stuff? Or anything else for that matter? Ah, unexpected in df4. Yep, yeah, the reason for that is you have your length.out equals 20 is outside of the parentheses for sequence, and also you've done sequence there with a colon instead of a comma in between the numbers. So you probably want it to look more like this right here. So that's an excellent question. What is the difference between class and type of? So it depends on the type of object you're looking at. If I go class vecnum, I get numeric. If I go type of vecnum, I get double. This is saying that it is a numeric vector, but it's specifically a double type vector. If I do something like, let's see, mat1 class, this says mat1 is a matrix. In R, matrices are also a type of array. But if I say, what type of matrix is it? It is, in fact, a double numeric matrix. So classes give you what is sort of the formal class, the object type. Type of gives you a more specific subtype of that particular object. It's hard for me to use the proper language for it because I want to say type when I mean class, and class is a class. So class returns the class of the object, but class is a formally defined thing. Classes behave a particular way in R. So if you look at question mark class, these are generic functions for getting object classes for object-oriented programming. The complex and full answer is that the class of an object determines what functions will be run on it when you attempt to run something on it. So for instance, if I say print mat1, this will display matrix 1 in my console. But how does it do that? What R is actually doing is doing print dot, a function you can't even directly access called print.matrix or print.array. Yeah, which you can't actually find directly. It could probably be called on with print.default. So R is an object-oriented programming language, and those classes you can pull out of an object tell it what functions to run when you give it an ambiguous function. You probably don't want to know that level of detail about it, but basically, if you want to know what kind of object something is, do class and type of, and they'll together sort of tell you what's going on probably. But formally, those things are used for something that's well beyond the bounds of this class, which is object-oriented programming. Next one. Still confused about list part 8. Select the third element of the fifth element and assign it. Yeah, that is a confusing one. Select the third element of the fifth element. Yeah, so this is saying, okay, what I want you to get is I want you to get the third element, that is the third thing that is inside the fifth part of list 4. Okay, so what you got to do is take list 4, go down to its fifth piece. So if we see what list 4 looks like, it's this big old thing. If I subset this down to its fifth thing, we're going to get all of this stuff here. That's the fifth part is just this thing. And then I'm saying I want its third element, this bracket 3 here, the number 16. If I give that, I get the number 16 popping out. This is a way to browse down the hierarchical structure of a list. Hopefully that makes a little bit of sense.
Yeah, that makes sense. So list can have many levels.
Yeah.
Okay, got
Lists can have an infinite number of levels, which gets really hard to deal with, but they can be really deep. Yeah, so this is saying, start with the list, go to its fifth element. Within that fifth element, go another layer deep into the third element.
And
So,
if we have more layer or level, we can add after that one. Is that right?
you just keep adding more.
Okay, got it. Thank you.
Yep, and it
That's
does them
helpful.
left to right. Okay, the next one. For the first question about vectors, why the factor vector and the numeric vector will be coursing into a character factor? Yeah, okay. So first question about vecfact. Wait, which one is that? Is that the text question? If you combine them, what class of vector would you get? Yeah, that's sort of unintuitive, isn't it? Because factors have an underlying numeric structure. If you combine a numeric variable with a factor, it pops out as a numerical one, not a character one. This is sort of a weird thing about it, and it's because factors are funky. Yeah. Why do they do it? Because factors underneath the hood are actually numeric. They just probably behave in a way you wouldn't want when you combine the two of them. So normally you wouldn't want to do it. Oh, and then onto there, yeah. Just submit both actually. If something doesn't work, like if it's in the HTML, there's like a wrong answer or something being funky, you need to be able to see the RMD also. Most of the time I won't have to look at them, but I always say submit both. Okay. Okay, ignore the lapply question. Yeah. Okay, anything else? Or did I not answer anything so far? Or if anything was unclear. I often gibber and make no sense.
Sorry, one last question on the questions of data frame, below data frame number 3. Can you explain quick what you mean integrating either the all function or any function to have the results in line?
Yeah, okay. So this is saying using equals to test to see if cbind data frame produce the same results. So this here was showing df5 and df6, right? So df5 looks like this, df6 looks like this, they look the same. If I say df5 equals df6, it's going to test each element one at a time to see if they equal the same thing. So you're going to get this big data frame filled with trues, which are all the tests to see if this number here equals this number and so on. They actually contain the same thing, so they're all true. But what you can do is, let's say what I want to know is, are all of these values true? I say all true. What this says is, this is going to look down every single column, every single row for trues. If it encounters any false, this thing is going to return a false. So the all statement is a way to convert lots and lots and lots of trues and falses into a single true or false. The same thing with any. Any would look and see if any of those are true, it returns a true. So in this case, all of them are true, so all returns a true, and so does any. The difference would be if there was like one false in here that wasn't exactly equal, all would return a false because they're not all true, but any would return a true because at least one of them is a true. Does that make sense?
Yeah, thank you.
Okay, anything else? Names of Chuck's cat. The name is Stella. What are you doing, you floof? What are you hollering about? Yeah. She's a good floof, but she's loud. Doesn't want to come in. She just wants to yell from over there. It's within an hour of dinner time. Anything else? Question 2 of questions about lists. I get null as a result. Question 2 about questions about lists. What are the dimensions of the model element? No. That is, it's true if you use the dimensions command. So if I run this and get LM output, it has no dimensions. The reason it doesn't have dimensions is about getting the 2, 3, 4, 5 dimensional dimensions of an object. But lists are a one-dimensional object. They don't have dimensions. They have length. So this is a tricksy one. The answer is its dimensions are, it's either length 12 or has no dimensions. Because it's one-dimensional in the like colloquial use of the term. Anything else? About 30 seconds. People might be typing. Yeah, you have a good evening too. I'm actually feeling unusually good today for having been very sick for 2 weeks. Yeah, a little better today. They got me on a very strong antibiotic for the sinus infection, but and it seems maybe to be working.
Thanks for your help.
Yeah, absolutely. Never knew a sinus infection could be so debilitating, but it basically put me out for 2 weeks. Okay, I will see folks on Wednesday. As always, hit me on the Slack channel, hit me with emails. I will answer what I see. I'll try and get to them relatively fast. I think I've been a little bit more responsive lately, but we'll see. I might get wiped out still later today.
Thank you.
See everybody. Bye-bye.